Good day, class. It's Sir Capistrana again, and welcome back to another lecture or another lesson for our Physics 1.1 General Physics. For today, we will be discussing free falling bodies. And by free falling bodies, this is actually one of the most familiar notion or familiar motion when we talk about constant acceleration. So by constant acceleration or nearly constant acceleration in free falling body, this is actually related to one of the first or second activity that we have done here in our class, which is the Galileo drop experiment. So, as you may have remembered on the results or your observations regarding the Galileo drop experiment, if we are to neglect air resistance or the effects of air and neglect the minuscule effect of rotation of Earth, we will actually experience or notice that any falling body, may it be heavy, light, uh, they will approach the ground at the same rate. Meaning to say, in that notion, acceleration is actually constant for any falling body. So, for example, you have dropped two streamline objects, say one is a stone and one is a needle. If you drop them from the same level or same height, and you let go of them on the same time, at the same time, you will actually notice that they will touch the ground, assuming that the ground is actually flat and leveled, they will touch the ground at the same time. So that is one of the concepts that Galileo and Aristotle actually studied or uh, experimented, in which they repeatedly done the experiment. So there are actually videos present in the internet wherein you can actually see or observe that given two objects, say a bowling ball or bowling ball or a feather, if you drop them at the same time with no air resistance, they will actually fall to the ground at the same time. So in here, we will actually be looking into that constant acceleration portion of free falling body, wherein, as studied by physicists, they actually came up with a number regarding this free falling body. So by free fall is actually an idealized motion. So by idealized motion, as I stated earlier, it is idealized because of its assumptions or the conditions wherein the free fall or the notion of free fall or the notion of constant acceleration of free fall will be observed. As you may see here, is actually a multi-flash or multi shot picture of a ball falling to the ground. And as you can see here, uh, using the series of shots of intense flashes, you can actually see the ball that, or you can see the image of the ball that is recorded on a photograph. And in that, you can actually see that there are equal time intervals for each flashes. So, kung kukunin natin yung, halimbawa, you started from here at this ball and you measure the distance that is traveled by the ball into here, into this portion at a given time interval, say t, and you measure the movements of the ball from the starting to this third ball to this fourth ball, you will actually uh, you can actually measure kung gaano ba kabilis yung pagtaas ng velocity natin or yung sinasabi natin the rate of increase of our velocity. In that, they actually computed the the idealized acceleration of this ball, wherein it is noticed that this ball is actually accelerating accelerating downwards, and using careful measurements, nakuha nila yung tinatawag nating acceleration due to gravity, which is denoted by the symbol G or the letter G. Wherein this G is actually, yung sa measurement na nakuha nila, it is actually approximately 9.8 meters per second square. And notice the meters per second square, it is actually uh, a measure of acceleration. So it is actually also equal to 980 centimeters per second square, or this is also equal to 32 feet per second square. So those are the measurements or the approximate value of acceleration due to gravity near the Earth's surface. So, yung exact value mismo, it may varies depending on your location. Bakit nga ba nagva-vary yan depending on location? Because it's more on kung ano yung topography ng lugar, kung ano ba yung distance ng lugar from or distance ng drop wala sa center of the earth. So, pero minuscule naman yung measurements na yan. And kung pag-uusapan natin yung ibang heavenly bodies pa, wherein it is G is actually acceleration due to gravity on Earth. But if we have other bodies like the gravitation or the acceleration due to gravity on the moon, it would be 1.6 meters per second square. Ito ay para sa moon. Near moon surface yan. And for sun, it is actually 270 meters per second square, which is greatly higher than the acceleration due to gravity on Earth. So kung titingnan natin, it's more on the size. Minsan, it's more on the size of the heavenly bodies. And syempre, pwede na rin natin i-account yung kung gaano ba ka-dense yung isang heavenly body. Okay? So that is, or by dense, I mean mass pala, not density. It is dependent on the mass of the heavenly body. But since we are here in near Earth, or usually nandito tayo sa surface ng Earth, we will be using more of the acceleration due to gravity on Earth's surface. So, in that note also, let me just remind you, uh, G is actually always positive. So, magkakaroon lang tayo minsan ng ng mga values na na magiging negative siya, but it doesn't mean na nagkakaroon tayo ng negative acceleration or deceleration due to gravity. It is more on the direction of the acceleration. So if we have positive acceleration due to gravity, that means ayun, pataas siya or pababa, or nakadepende kasi yun dun sa reference point na gagamitin natin. But most of the time, we may have negative G, but the value of G itself is always positive. Okay? So, in that note, I have here some examples that we may use para hindi tayo malito, or magkaroon naman tayo ng idea kung paano to nag-work. So again, since these are problems involving constant acceleration, we will be using the formulas that we derived last time on our discussion regarding motion along a straight line, wherein we have here constant acceleration. So I have here this, ayan, nandito pala yung note. Note, G is always positive, or acceleration due to gravity is always positive. Okay? So, let's move on to the problems. So, this is one of the basic, basic problems regarding free fall. So, we have here a free falling coin. So, for example, I have here a 1 peso coin is dropped from the rooftop of, wala dapat space yung rooftop na yun, rooftop of a high-rise condominium building. Determine its position and velocity at 1 second, 2 second, and 5 second. So, i-note muna natin yung mga values na meron tayo. Since walang sinabi kung meron bang additional na force na idinagdag dun sa pag-drop ng coin, let's just assume that this is actually a free-falling body. That means we actually have here a constant acceleration. So by constant acceleration, we have here, since sabi niya may building, say building, rooftop ng building. Nandito ka sa ledge, dinrop mo yung coin pababa, not necessarily nilagyan mo ng force. So ano daw yung magiging position niya or position and velocity. Halimbawa, ito yung ating time zero. So sa time zero, we have there our y, which is equal to 0. And also we have there, yun yung first position natin. And bakit y yung ginagamit ko instead of x? Because ang ginagamit natin ngayon, imbes of horizontal, we are dealing with vertical numbers. And we have here a vy. Since there are no initial velocity that is introduced to our free-falling coin, we will have here a free-falling body that has an initial velocity. Nakalimutan ko yung O, v naught y, which is equal to 0 meters per second. And as we have assumed, we actually have here a downward acceleration, which is actually equal to org, which is actually equal to 9.8 meters per second square. So, ang kailangan nating malaman ay kung ano yung mga values kapag yung ano na tayo, yung sa first second natin. So, yan, this will be t is equal to 1.00 second. Hindi natin alam kung ano yung y niya. Hindi rin natin alam kung ano yung vy natin. So also, we also need to measure or tingnan kung ano ba yung nung t is equal to or time natin is 2 seconds. Then di natin alam yung y niyan, hindi rin natin alam yung vy. And also for the fifth second, so kailangan din natin alamin yung kanyang position, which is y, and its velocity, which is unknown. So, yan yung mga gusto nating makuha. And for this one, actually, since we are dealing or we are looking for velocity and y, we will actually use equations 5 and 9. So, equation 5, para dun sa ating velocity. So, kung maalala nyo yung equation 5 na sinabi natin, that will be our velocity will be equal to our v naught y plus acceleration times time. And as you may have remembered, this acceleration of y due, since our assumption is this is a free falling coin, we will have here vy will actually equal to v naught y plus negative g times t. So, baka may nagtataka sa inyo, Sir, bakit negative g? Kasi kapag ang consideration natin ay kapag pataas ay positive, since downward yung motion, negative yung magiging g natin. Pero, ayan. So, yan yung magiging formula natin to get the y's of our equation there. So, papaltan-paltan lang natin yung ating t. And as you may have remember, our v naught y is actually 0. So our Vy will actually be equal to 0 plus our negative g times t. Meaning to say our V naught y will be just 9.8 meters per second square or negative 9.8 meters per second square times the time. So we just need to substitute 1, 2, 5, 1, 2, and 5. And for the our position, which is y, we'll be using equation 9, wherein our equation 9 is actually y is equal to our initial position, which is y naught, or y sub 0, plus our v naught y, our initial velocity times time, plus 1 half acceleration sa y natin, and we have there t squared. And as you may have remembered, y0 will be 0. V naught is 0, meaning 0 times time, 0 pa rin siya. And we will just be left with this. So our y will actually be 1 half, and ay natin is negative g because falling down. Then we have there our t squared. So meaning to say, this will be just 1 half of negative 9.8 meters per second square. Multiply lang natin yan dun sa time square. So it is more on substituting the values of our t to this formulas. So para dun sa 1 second, oh, hindi ko na naman sinulat yung mga sagot. Anyway, we have here, okay, t is equal to 1.00 second. So, yan na lang gagawin natin. We just use this formula for our Vy. So, position, ang velocity natin ay Vy is equal to uh, negative 9.8 meters per second square. We just need to multiply that to time, which is 1.0 seconds second. And as you may see here, one of the second in our acceleration will actually cancel out. And para ma-cancel out din to, then we will have their meters per second na lang. And negative 1.8 times 1, that will be uh, negative 9.8 meters per second. Ibig sabihin, at time is equal to 1.00 seconds, its velocity is actually negative 9.8 meters per second. So, anong ibig sabihin nila itong negative dyan? Since it is falling down, negative lang yung direction, but not necessarily negative yung acceleration, ay yung velocity niya. Okay? Ang ibig ko lang sabihin doon ay hindi non-existent yung velocity. The negative there is just for the the direction of our movement. Okay? So in that, let's compute uh, for the position at time is equal to 1 second. So we have there 1 half times negative 9.8 meters per second square. Alright? Then we just need to multiply that to 1.0 second square. 1 second square is just 1 second square. Multiply lang natin ulit yan dito. So, ganun pa rin siya. Negative 9.8 meters na lang siya kasi magka-cancel out yung second natin. And we have there 1 half of 9.8, which is 4.9. So we have there negative 4.9 meters. So its location from point 0, nung bumagsak siya, nag-drop siya ng 4.9 meters pababa in just 1 second. So that is our free fall. Okay? So for 2 seconds, when we are talking about 2 seconds here, if our time is equal to 2 seconds, Ganun lang din yung gagawin natin. Kung mako-compute natin dyan, our velocity will actually be negative 19.6 meters per second. And our y will actually be negative 9.8 meters. Tama ba? Check ko muna ha. May mali ako. But anyway, we have there, let me compute. So, para dun sa ating, sa ating velocity, we just need to multiply 2 to our negative 1.8. So, that is 19.6. And if we have there 2 square is 4, we multiply that to the 1/2 of 9.8. So, we'll have there, ayun, tingnan mo, mali ako. So, that will actually be 19.6 meters. Okay? So that is our position. So from time 0 to time 2, the object or the peso coin actually dropped 19 meters or 19.6 meters below. And lastly, for kapag our time is 5 seconds, 5.00 second. Ganun lang ulit yung gagawin natin. We just need to substitute 5 into this time. So we'll have negative 9.8. So we'll have 9.8 multiply that to 5. So we'll have there our velocity will actually be 49 meters per second. And for the position, our y, so we'll have there plug in lang din natin ulit yung 5 dito sa ating t square or sa t. So we'll have there 25 because 25 is just 5 square. We multiply that the 1/2 of negative 9.8. So we'll have there 122.5 meters. Okay? So as you can see here class, ganong kalaki yung increment nung ating free fall depending kung gaano kataas yung drop point natin. Ano? So as you may encounter here, 9.8 meters per second squared acceleration is actually a high rate of increasing velocity. So as you can see here, from 1 second na negative 9.8 meters per second lang, after a second, 1 second lang ulit yung nag-pass, naging ano na siya, naging negative 19.6 meters per second. And after 5 seconds, 49 meters per second na siya. Hindi nyo siya nai-imagine na meters siya, pero kung isipin nyo, isang bagay na nag-travel agad ng 49 meters in a second, yes, that's fast. So, ganun yung rate ng increase ng fall. Kaya pag sinabi natin, if you free fall from high space, tapos bumagsak ka sa ground, medyo malaki or lala yung injury mo. But anyway, that is just for free fall of coin, which neglects dahil dun sa minimal na air resistance na pwede niya matanggap. Ayan. Pwede siya mag-fall ng ganyan. Pero this is again an ideal meaning to say hindi ganyan lagi nangyayari. Kailangan pa nating i-account yung resistance and all, but for the vector of acceleration, velocity, displacement, free fall acceleration will actually be the simple. Right? And lastly, and not lastly, and for another example, I have here this problem. So, up and down motion. So, paano naman nangyari dito? So for this problem, you throw a ball vertically from a roof of a tall building that leaves your hand with an upward speed of 15.0 meters per second. The ball is then in free fall. On its way back down, it misses the building's railing. Ibig sabihin, hindi mo siya rin siya nasalo. And we need to find the following. So we need to find the ball's position and velocity at 1 second and 4 seconds after leaving your hand. So this part of the problem is similar to our first problem. And we have here the ball's velocity when it is 5 meters above, above dun sa starting point mo. And we also need to find the maximum height that the ball reach. And also we need to find the ball's acceleration when it is at its maximum height. So yun yung apat na kailangan nating makuha. So basically, i-ano muna natin siya. Drawing muna natin siya. So, nasa ledge ka ng building. Medyo ano no, risky mag-experiment sa physics kasi kailangan mo palang tumayo sa gilid ng building. Joke lang yun. But anyway, here's the motion. That is the building. So sorry kung medyo hindi siya straight. Ano? So let me use another color pen para lang illustrate natin ito maayos. So basically what happened is you release the ball, it travels upward, then it moves downward. So that is the ideal movement of the ball. So the problem actually asks us if what is the ball's position and velocity at time is equal to 1 second. So parang ganito yan. So if we have here this portion, this can be the t is equal to 1.00 second, wherein if we note this level kung saan ka nag-throw ng ball as y is equal to 0, we need to determine kung ano yung height niya dito. So, hindi natin alam yan. Bale, ito ay ating y naught. Hindi natin alam kung anong level tong 1 second na yan. And also, siguro nandito na yun, 4 seconds. So, sulat natin dyan. We need to determine dito kasi sa portion na to, this will be our time is equal to 4 seconds. And we need to determine, kalimutan natin yung velocity nito. So, Vy is also unknown. And for this one, we also need to get get the position, which is y. And also, we need to also determine the velocity, which is Vy. Okay? And let me just reiterate. At time, let's use another color pen. So, this is our time is equal to 0 seconds, wherein our initial position will actually be 0 meters. And our initial velocity, as stated in the problem, is actually 15.0. Let me just write it. This. So that will be 15 meters per second. Alright? And for B, kung meron naman daw tayong y is equal to 5, oh, nawala. Anyway, alright. Drawing ko na lang ulit. So we have here the building, we have here the throw. For for the first portion. So we have here time is equal to 0 seconds. We also have here y is equal to 0. So meaning to say this is y not is equal to 0. Then we have here our v not y, which is actually 15 meters per second. Also, what we need to do here is we need for one, dun sa first problem, we need to account for the first second. Yan naman. Sorry about that. First second nung nung flight nung bola. So that will be our t is equal to 1.0 second. And di natin alam kung ano yung by niya. Also, we don't know this level ng y. Okay? So, next natin is we need to get uh, we also need to get the velocity of the ball in y is equal to 5 meters. Pinrecision ko lang yun dyan kasi hindi ko alam yung mismong pwesto ng 5 meters natin. So, in that, we need to determine the uh, by in that area. And for letter C, we need to get the maximum height here, meaning to say, we need to compute for the y in there. Actually, dito sa point na to, kung mapapansin nyo, kapag yung isang bagay na inihagis mo sa mataas na lugar ay maaabuti na yung pinakamataas yung pwesto. Actually, mag-slow down siya to the point wherein we will have there our Vy is actually equal to 0 meters per second. And lastly, we need to get the ball's acceleration in here dito sa taas. So, yun yung kailangan nating makuha. Okay? So, bali tatlo or ilan yan? Madami-dami tayong i-compute. So, this will be your A. Nakalimutan natin yung dito sa baba. Yung sa 4 meters natin. 4 seconds natin. Kailangan natin alamin yung y dyan. And we also need to compute for the by. So, yan yung A natin. For our B, this will be our B. Uh, we need to compute for the velocity of y. Velocity of the ball at y is equal to 5 meters. And also, we need to compute for uh, the maximum height. So that will be our C. And for our D, we need to compute for the acceleration at the maximum height. So that will be our problem. Medyo tedious yung pagka-compute nito. So medyo pinag-iwahiwalay ko sa class. So in hindsight, we have here this first part. Kunin muna natin yung letter A. So for letter A, as I said earlier, this is actually related to our problem earlier on the free-falling coin, wherein we will be using equation 9 and equation 5. So again, equation 9 will be y is equal to y naught plus our initial velocity or v naught y times time plus 1/2 of our acceleration, which is acceleration due to gravity, kasi ang sabi natin kanina, it is actually on free fall. And we have their time square. Okay, so that will be one of the formulas that we'll be using. We can actually simplify this by substituting some of the given dun sa problem natin. We know that our y naught is actually 0, so we will have there 0, our initial velocity is actually 15 meters per second. So we will have there 15 meters per second times time. Also, we have there our acceleration due to gravity. So we'll have there 1/2 times negative 9.8 or 9.80 meters per second square times our time, which is t squared. So that will be our formula. Tanggalin lang natin yung zero and we have this formula. You just need to substitute the values of t for for each given. So first, let's use 1 second. So for 1 second, y at 1.0 second. So the position at 1 second will be, we will have there 15 meters per second. We just need to multiply that to 1 second. Okay, so the second will actually cancel out. And we will have there 1/2 of 9.8 meters per second square. And we need to multiply that to the square of 1 second. So magkakaroon tayo ng second square dyan. So that will be uh, cancelled. Okay, so we will have here 15 meters na lang siya plus 1/2 of 9.8 times 1, that will be 4.6 meters. So we will have there negative, sorry. We have their negative, so this will be 15 plus negative 4.6, that will be a positive 10.1 meter. So that will be for 1 second. Same can be done with 4 seconds. You just need to substitute 4 seconds dun sa ating dun sa ating mga t, and you will have there your y at 4 seconds will actually be negative 1 point 18.4 meters. So as you can see here, we have here positive and negative values for our positions. But ito actually ang sinasabi lang niyan, from your original position or original position ng bola, if our y is positive, it just means that it is still moving upward, okay? Or it is in the higher position from our starting point. Ibig sabihin, nasa may bandang taas pa siya. Okay? Mula ron sa original na pwesto ng bola sa kamay mo, nung pagkahagis mo sa kanya, the ball traveled 10.1 meters from your hand. Gawa ng ating initial velocity na 15 meters per second. But actually, kung titingnan nyo, it is actually slowing down because the acceleration is actually moving downwards. Okay? And for the position at 4 seconds, we have there negative 18.4, meaning to say from the original y level, it is actually lower. It is lower by 18.4 meters. That's why it is negative. And for the velocity part, as you may have remembered, we will be using the equation 5 or our equation 5, wherein our Vy will be equal to our initial velocity, which is v naught y, plus our acceleration times our time. This will be actually equal to 15.0 meters per second plus acceleration, which is acceleration due to gravity. So we will have there negative 9.8 meters per second square times our time square. Just like the first portion of this part of the problem, ganun lang din gagawin natin. We just need to substitute the value of t in sa may mga t. So meaning to say, in this portion of the formula, we just need to substitute 1 or 4. So in that, sige, hayaan ko muna kayo mag-compute. Paki-pause muna yung video. So, kung tama yung ginawa nyo, so for our, at 1 second, our velocity will actually be positive 5.2 meters per second. And at 4 seconds, our velocity at that point will actually be negative 24.2 meters per second. Okay. So meaning to say, at 1 second, the ball is still moving upwards. Okay. And it is actually decelerating because acceleration is towards the ground. And rather, acceleration is downward. And at 4 second mark, our velocity actually is negative 24.2 meters per second, meaning it's moving downwards and actually it accelerated. Mas tumaas yung velocity nito. Okay? So that is for letter A. Sorry, medyo tedious. But anyway, so class, kapag may questions kayo, pwede kayong mag-comment sa video na to at pwede rin kayong mag-chat sa akin. Okay. So for letter B, the question for letter B is what is the ball's or find the ball's velocity when it is 5 meters above. So by 5 meters above, meaning to say original position, this is our y is equal to 0. We need to measure its velocity at y is equal to 5 meters. So, yan yung kailangan nating alamin. So, for this one, we will be actually using our equation 10. When or in our equation 10 is actually Vy square is equal to V naught y square plus 2 times our acceleration. Okay, tama. And we have there our displacement, which is y minus y naught. So, kung titingnan nyo class, may mga values na tayo ng mga nandito. This will be actually our our Vy square will actually be equal to V naught square plus our acceleration is acceleration due to gravity, meaning we have here 2 times negative g. And we have there our given, our y naught is 0, and we have there our y. Okay? So, happens here is just we just need to substitute our values. So, this is still by squared. So, we have there 15 meters per second square, okay? Plus 2 negative g, which is negative 9.8 meters per second square. Kalimutan yung meters per second square. That will be multiplied to the position, y, which is actually 5. So we have there 5 meters. Okay? Upon solving, you may notice that you will have here 15 times 15, that will be 225. Then we have there 5 times 2, 10. So we will have here 98 meters square second. Okay? Tama ba? Check lang natin class. So we'll have there 15 times 15, mga 225. So we have here 225 meters square second square plus we have there negative 98 meters square second square. Kapag pinag-sama niyo yan, you will have there positive. We will have here 127 meters square second square. And as you may have noticed here, we have here a squared value, meaning to say we need to get the square root of that. And we will be left with Vy is actually equal to positive negative 11.3 meters per second. So maaaring yung iba sa inyo nagtataka, Sir, bakit negative, positive negative 11.3 meters per second square? So, as you may have remembered, mula dun sa ledge, nag-travel ka pataas, nag-travel ka ulit pababa. Ibig sabihin, dalawang beses kang nagkaroon ng 5 meters. Yung initial mo na dito at yung pababa na siya na nandito. So, in this point, it has a positive value because it is moving upwards. And within this point, magkakaroon ulit siya ng negative na value kasi it is moving downward. So that is the velocity, or that will be our velocity. It can be positive 11.3 or negative 11.3 meters per second. Okay, so doon na tayo sa mas nakakalito pa. Okay, so our next problem is we need to get the maximum height. Again, for this one, we will actually be using, since we only have our values for the Vy, which is actually, sabi natin kanina, kapag na-reach mo yung maximum point mo, your Vy will actually be equal to 0 meters per second. Okay? And we also have Y naught, or initial position natin, which is 0 meters. Also, our gravity is constant, which is actually equal to negative g. Bakit negative g? Because it is moving downwards. So for this one, since wala tayong notion nung time or hindi natin alam yung value ng time dun sa maximum height natin, we will again be using equation 10. Or in equation 10, again, is equal to our Vy square equal to our V naught y square plus our 2a, or 2 times acceleration of y. Then we have there our displacement, which is actually y minus y naught. And if we are to substitute some of the values here, say since wala na siyang velocity kapag nakuha niya na yung or nandun na siya sa maximum height niya. So we will have there 0 is actually equal to our V naught square. So that will be 15 meters. 15 meters per second, and you just need to square that. Huwag pala yata muna ito. Okay, but anyway. So we will have here our V naught y square plus our 2g, 2 times negative g, times, since yung y naught natin is 0, we will just have their y. So simplify lang natin. This will be equal to 0 times v naught y squared plus, not plus, can be negative 2g. So we'll have there negative 2gy. Okay? And since kailangan natin yung y, we can isolate that. So what we can do here is we need to transpose. So we'll have here 2gy is equal to our v naught y square. Divide the whole equation with 2g. And we will be left with y is equal to v naught y square all over 2g. Okay? So, para ma-compute yung y natin, we just need to substitute all of the known quantities, wherein we have there an initial velocity, which is 15 meters per second, and we just need to square that. Then we have here 2 times 9.8 meters per second square. And upon computation, this will be positive 11.5 meters. So that will be our maximum height. Okay? So it is positive because, as you may have remembered, it is thrown from y0 upwards. So you should expect a positive value there. Okay? And for the last part of this problem, we need to identify the ball's acceleration when it is at its maximum height. Sige nga, walaan nyo kung ano yung sagot dito. Okay. So, some of you may say na since sabi kanina na yung at the maximum height, ang ating Vy is equal to 0 meters per second. Yung iba iisipin sa inyo na ang acceleration dun sa highest point na yun will actually be 0 meters per second square. But that actually is false. Why? Kasi pag sinabi natin, if we have at the highest point or at the maximum height, you have uh, a velocity which is 0 meters per second. Tapos sinabi mo na, and you say that your acceleration is actually equal to 0 meters per second square, it just means that mag-stay dapat yung bola doon. Or mag-stay dapat yung object kung saan mo siya tinrow. Kasi hindi siya mag-accelerate. Hindi magbabago yung velocity natin. So, in that, actually, this is just a simple problem. If you say that your motion or your movement is free fall from the start, and there are no external forces or external or additional forces that is applied to your object, it just means that it will retain your free fall acceleration. Meaning to say, our acceleration will be just equal to our g, or our negative g, which is actually equal to negative 9.8 meters per second squared. So that will be the answer for your letter D. Okay, so, and that will be the last part of this set of questions. And in that, I actually have another or additional question for this problem. So you throw a ball vertically from the roof of a tall building, same scenario, the ball leaves your hand with an upward force of 15 meters per second. The ball is then in free fall, and on its way back, it just missed the building's railing. Find the following, which is isa na lang. At the time after being released, the ball has fallen 5 meters below the initial position. So, ano yung time sa ano na yan? At what time after being released has the ball fallen 5 meters below from the initial position? So, meaning to say, building, initial position, that is y is equal to 0. Nag-drop yung ball papunta rito. You measured here, this is y is equal to negative 5 meters. Bakit negative? Because below, that is below y0. So what we need to compute here is, what is the time? So that is our dilemma here. So in here, class, we can actually use our equation 9. Okay, nanawa na kayo sa equation 9. So by equation 9, we will be using this one. So y will be equal to our y naught plus our v naught y t plus the 1/2 of ay, which is actually negative g times t squared. Okay. So in here, what we can do is we can actually transform this problem into what we call a quadratic equation. So, kasi hindi natin ma-isolate basta-basta kasi yung mga time natin dito. So, what we can do here is, form a quadratic equation using this problem. As you may see here, y is actually a known number here, wherein y is equal to negative 5. Okay? And we also have here our y is equal to 0. So this is also a known number. This is 0, just 0. So meaning to say, we can actually transform this equation in a form that we may have a t square plus b t is equal to some constant c. Ay, no, not equal, plus constant c equal to 0. So, yan yung pwede natin gawin dyan. Ibig sabihin, we just need to rearrange this equation wherein mag-transpose lang tayo, wherein we will have here 1 half g kasi transpose natin siya sa kabila, t square. So, nandyan yung t square natin. Plus, we will have there our negative v naught y. Bakit siya negative? Kasi from this part, tinranspose natin siya sa kabila. So, we'll have there our t. And we have there plus our y minus y naught equal to 0. Ibig sabihin lang dito, class, we will have here an equation wherein our a, we will have here a quadratic equation which has our a is equal to negative 1 half g. Our b is equal to negative v naught y. And subscript dapat yung nasa negative v naught y. And our c will be equal to y minus y naught. Okay? And kapag meron ka na nito, pwede mo na actually ma-compute yung t using our quadratic formula. So, yung sa mga nakalimot dyan, kung ano yung quadratic formula is just x is equal to negative b. Capital na yung gamitin natin. Negative b plus or minus square root of b square minus 4ac over 2a. And as you may notice here, pwede natin yung gawin dito kasi quadratic equation na yung form natin dyan, wherein we can actually compute for the t using this formula. Kaya, magkakaroon tayo ng ganito. So, we'll have here t will be equal, or time will be equal to negative v naught y plus or minus the square root of our b naught y minus 4 a natin is negative 1 half g. C will be y minus y naught all over our 2a, which is 1 half g. And upon simplifying, magkakaroon tayo ng v naught y plus or minus, we'll have here v naught y square minus 2g y minus y naught over g. So, ang gagawin nyo na lang natin dyan, you just need to insert, or you just need to plug in or substitute the values for this equation to work. So, bali mangyayari, you just need to substitute 15 meters per second squared to all your v naught y. Alright? Then, for your 2g, you just need, or your g, you just need to substitute 9 point, right? And for your g, you just need to substitute 9.8 meters per second square. And for your y will actually be equal to negative 5 meters. And your y naught will be equal to 0. And you will actually pag kinumpute nyo to, magkakaroon tayo ng dalawang sagot wherein we have here t which is equal to negative 0.3 seconds. And also we have here t which is equal to positive 3.36 seconds. And sa pagkakaalala nyo, pag sinabi nating time, hindi natin pwedeng gamitin to because this one is actually negative time, and as you may know, wala tayong negative time. So, the time from after being released na na-reach, paano ko ba i-replace? The time the time is equal to 3.36 seconds after being released that the ball fallen 5 meters below the initial position. So, ganyan natin siya i-compute. So, yun yung magiging issue minsan, class, kapag magko-compute tayo ng free fall when we are computing for the time. Because the time component of free fall is actually harder to quantify or to calculate because time is always attached to the V naught or the acceleration. So, ayun, when it comes to this type of problems, ganito yung gagawin natin. So, in that, kailangan ko na kayong sabihin na kailangan nyo talaga ng calculator or scientific calculator when we are dealing with this type of problems. Total, magagamit nyo rin naman yung cycle nyo when kapag ang pinag-uusapan na natin ay stat. So, ayan. Magiging madugo ang buhay natin kapag wala tayong cycle. Okay? So in that class, I will be ending this discussion on free fall. So expect after you have submitted uh, your past activity, which is activity on motion along straight line, expect another activity regarding free falling body. In that, I'm ending this lecture here. So thank you and have a great day. Goodbye.